What's up guys, welcome to my new cheat series. The kernel driver is going to be reading and writing memory, and the user mode client is going to be doing most of the calculations, and I'll probably add an overlay as well, so it'll render wall hacks and stuff like that. Basically we're going to hook a random function here. The one I'm using in this video is called query composition surface statistics. Okay, big word. So what we're going to do is I'm going to show you guys in my virtual machine here after I explain this how to find this, reverse this, and we're going to look at the assembly and stuff like that. And we're going to make our shellcode, and basically what it's going to do is it's going to say move our hook address, which is going to be the address of our function in our driver, or however you load your driver, it's going to be wherever it is, into racks, which is a register, and then we're going to jump to racks, which is it's going to jump to our function and execute our function. And then our function is basically going to have access to the parameters of this function here. And what's the parameter going to be? It's going to be instructions for our driver, and we're going to say, let's say, I don't know, this is completely example. Let's say there's a boolean read, and we say, is read true? Yes, it's true. Let's read process memory, okay? Otherwise, if write is true, we're going to write process memory, and then after all that, we're going to return status success, which means it's basically just not going to run the rest of this function here. So essentially, what's going to happen is every time we call this function here, or every time this function gets called, it's going to call our hook, and then it's just going to return. So, okay, we've got our kernel hook in place. Now, how do we actually call this function from user mode, from our client, right? Well, what we're going to do is we're going to load a library, and we're going to export the function, and then we're going to make our own little struct here, copy memory, whatever, and we got this little bool, read, write. And we make a pointer. We're going to set whatever instructions we want. There's going to be much more variables because we're going to need a buffer address, the actual address we want to read, the value to write, etc. Then we call the function from user mode, which calls the function in kernel, right? So we call that with the parameters that we want. It calls the kernel version. The kernel function runs. What does it do? Runs our hook, goes over to our driver, runs our hook function, and we get to access the parameters. And it's our struct, so we say, you know, is read true, whatever, like I explained before. Once we do all the instructions, we return. Okay, simple as that. So the user mode calls the kernel function where our hook is in kernel mode. Our hook runs. We check the instructions, the parameters, whatever. Maybe we didn't even call it, so if none of these are true, whatever, it still returns. Okay, and that's pretty much it. So we get to communicate with our driver and run this function with instructions whenever we want. Oh hey guys, how's it going? So we're going to disassemble the function here. I'm going to use WinDBG. So I'm in the debug program here. I'm going to click kernel debug. Since I'm in a VM here, I'm just going to do a local debugging. Alright, so once we got the command line open, going to have to do a few commands here. So we're going to have to attach to it a session-space process, and you can do that with the explorer.exe, like that. Oh, not like that, but this is how we get the code, and then go to .process/p, and then put the code here, and there we go. So now we need to reload the driver we want to disassemble, which in our case is dxg kernel.sys. Oh, I forgot that you gotta put /f before the name. And then that's it. So we can go into the disassembly view and just type in the function name up here, and we'll see the function. So the name of the one we're doing is anti-query. Actually, first I'll show you guys how you can find the functions. So hopefully it lets me restore the pages. Yeah, here we go. So I'll leave a link to this down below. This is just from Firefox. It's a table pretty much of a bunch of functions. So some of these aren't going to work, but most of the composition ones do in my experience. So just look through them. These ones won't work, I'm pretty sure. With NTD composition, I'm pretty sure that they won't work. But if you go down lower, these ones usually work. So handle info, I think this one's fine. So here's our function here, query surface statistics. So you can just copy that, chuck it into the WinDBG up here, paste it, and it'll show you the function straight away. Now I'll show you guys how to find like another function if you guys want to make your own hook. Let's say you guys choose this one, handle info or something. This one looks pretty good actually. So I'll try to find one that is like a bad one, probably this one. Just so you guys know, from my experience at least. Alright, this one looks good as well. Okay. Yikes. This one. What the where? Okay. This one, surely. Unbind surface, bro. Alright, here we go. So functions like this, where they have this security cookie instruction here, yeah, you don't want to hook that one, okay? In my experience, it just blue screens you no matter what you do. So I'm pretty sure it's like some sort of security check, obviously. So if it's got this security cookie thing, don't hook that function. Look for ones that don't have this here, this security cookie thing. So make sure your function doesn't have that, and you should be good. I just went through like 2 or 3 just now in a row, and none of them had that, so you should be fine. But just so you know, I try not to hook functions with that. If it's got this critical region thing, that's fine. You can hook those. But the security cookie ones are a bit of a yikes. So I'm going to go on the one that I'm using for the example. It doesn't really matter. At the end of the day, you can use the same shellcode for like most of these functions. What we want to do is we want to do a move and a jump. Now the move racks is going to be 2 bytes, so that's move racks, and then it's going to be another 8 bytes for our function address, right? So that's 10 bytes in total for the first address. But basically for the first instruction, we're going to need 10 bytes. Then for the jump racks, we're going to need another 2 bytes. So we only need 12 bytes for this hook, okay? Just so you guys can kind of wrap your head around it a little better, I've got the driver here that I'm going to code in this video. I've got it already compiled, obviously. I'm going to run it here. This is just KD mapper. You guys, I'm sure you can get KD mapper yourself. So I'm going to load this driver, and I'm going to show you how it changes the function here, so you guys can see what we're doing exactly. Now I'm just going to run it. There we go, and I'm going to reload the function basically. So I'm just going to delete the S, put the S back. There we go, it's refreshed. You can see our hook's in place. So what do I mean by that? Well, you can see this first address has a lot of bytes. So you can see the first address here, move racks, and then it's got our function address. So this is the address of our hook function right now. And then after that, it's just jump racks. So we're putting our function address into racks, and then we're jumping there. Okay, simple as that. And then the 5.7 turned into push RDI. Interesting. Yeah, so that's pretty much it. So every time this function gets called, it's going to run this line, puts our function address into racks, and then it jumps there. That's it. It executes our function. So I think this is our function here, the hook function, and basically all I have it to do right now is just return. And yeah, you can see it right here. It just returns. So yeah, that's basically the hook. That's how you find a function, how you disassemble it, you know, look at the bytes, whatever. Now I'm going to show you how to actually code the driver. So let's start coding this driver. It is not going to be a USB driver. It's going to be a hack. Why does it say USB? Is that the wrong one? Yes, that is the wrong one. So you want to do an empty KMDF driver apparently. I'm just going to call it this one. First thing I'm going to do is some of the settings, the project settings, to help you guys get a successful build. So very cool. So you want it to be x64 release, of course. Whatever. You want to make sure character set is not set. What else? Inf2cat, you don't want that to run. Driver signing, you want that off. Okay. What else? Linker. Oh yeah, you want to make sure driver entry is actually driver entry. And there's one more thing I forgot about it. I think that's it, or whatever. If we run into a problem, I'll show you guys how to fix it. So, first thing I'm going to add here is a bunch of the definitions for like the undocumented functions and stuff that we're going to use. Yeah, so the way you can find this kind of stuff is you can just go on React OS, and there you go. You see like the function definition there, you see the arguments, what it returns, stuff like that. So React OS is really good for finding these kind of undocumented structures or functions. So you can try and implement them into your Windows stuff. Yeah. So if you guys want to just copy it out from the video, here it is. It's not too much. I'll just scroll through. It's got a couple of includes here, and then it's got these structures here and an enum. And then a couple function definitions, which we're going to need. So yeah, you guys can pause the video, whatever. Shameless plug, there's a link down below to my Patreon, might be top comment or in the description. And on my Patreon, $5 a month, you can get access to all my source code from every single one of my videos. So try that. It's basically a one-time payment because I only upload like once a month. So yeah, man, just $5, you can get access to all this source code. You even get a supporter role in my Discord. You get access to locked channels in my Discord where I actually read them and reply. Of course, if you're asking dumb questions, simple questions that can be answered by Google, I'm not going to entertain them. I'm probably going to troll you, or someone else is going to troll you. Speaking of Discord, there's going to be a link down below, either pinned comment or description, where you can join my Discord. We got a bunch of people there. So we've got the definitions here. Next thing is we're going to do next thing is going to be a memory header here. We're just going to define some functions. So we want to include definitions and then define some functions. So first one we're going to need is getting module base. And that's going to take a parameter of what module we want. Next is going to be to get a module export. So and then we're going to need two more functions here. We're going to need a little write memory function. It's going to need the address, buffer, and the size. And then we're going to need write to read-only memory. Cool. So include memory. Alright, so we're going to code the functions now. Going to have to include that header file there. First function. Hopefully it's zoomed in enough for you guys. I'll do a little bit more because I know some of you guys like to code while watching the video, and so having it zoomed in helps a lot. So we want to query the module information here. So we're going to pass a little enum value there. And then null, and then we're going to pass the bytes here, and then pass that. Cool. If not, So if byte is invalid, we want to return nothing, and then otherwise keep going. Okay, so when you're making a pool here and you make a tag, basically you pass this hexadecimal value, which is converted from text. So that's going to be the name of your tag. The one I'm just going to make one right now, show you guys how you can make it. So like text to hex, go here, put in whatever text you want. I'm just going to do null, and there you go. That's the hex you want to put in for the tag, which isn't copying and pasting. So there you go. And then you want to do 0x, get rid of the gaps. Okay. There you go. And that's it. It can only be 4 letters, I'm pretty sure. Alright, so that's our tag there. And it says null. You know, because that's... we're going to say if anti-status. Whoops. Success, and then we pass status, return null. Coolios. Sorry for not talking, guys. I woke up like half an hour ago and I'm drinking coffee and trying to focus, and I really do be vibing, you know? I really do be vibing. We've already done a string comparison. Oh my god. So I'm gonna just explain some of this code because I like literally disconnected IRL. So getting a list of the modules, okay, and then we're looping through the modules. This is equivalent, if you're doing like a user mode external, this is pretty much the equivalent of taking a snapshot of the process list or whatever, or fuck, what is it, the module list or some shit. So we're looping through these modules here, we're comparing the name of the, so we're comparing the path name of the, so we're comparing the name of the module that we're looping through to the one we passed in the argument, and we're seeing if it returns 0, it means it matches. So if it matches, then we found the right module. So we want to save some of the information from that module, don't we? So we obviously want the module base, right? Because that's what we use for the address calculations. I'm sure you guys already know this. I mean, if you're doing kernel kernel reversing, kernel programming, I mean, I'm sure you know all this, but I don't know. I just don't know what else to talk about when I'm coding, so alright, cool. So saved the module base and the module size, and then we can break after that, clean up here. So if modules, we want to free that, and I had a tag modules, and you can pass null for that, doesn't really matter. I like to use null instead of 0 because my name is null. Cool. And if you look at what null means, guess what it means? It literally means 0. So after all that, we want to return obviously what we got, which is module bar say. Alrighty. Now that was probably the biggest function in this like entire fucking program, so that's why I went into Super Saiyan. Cool. These other functions are pretty simple. So next is going to be get module export a. I believe that's what we called it. Yep. Cool. And that's got char pointer. Culios. Oh my god. Alrighty, so we're gonna need module pointer, and that's gonna be returned from this bad boy. We can pass module. I think I've got Rhino, bro. I'm dying out here. So go to void pointer, the module. And then basically we just say, is that valid? If it's not, you already know what we do. Return null, don't we? Alrighty, so otherwise it works, and then we just return RTL find exported routine by name. And the routine name, which is going to be the function name essentially, which we want to hook. Cool. So that's that function. Then we're going to need the write memory functions. So we're going to make a nice small write memory, a little kind of like a wrapper here. It's going to need the address, buffer, and the size. And all it's going to do is just use this definition here, RTL copy memory, and basically all that does is it calls mem copy. Okay, so you can use mem copy or that interchangeably, but I believe the big English, but I believe the parameters are a little different. Not too sure though. So basically if that failed, we were returning false, otherwise we want to return true because it worked. So there you go. If you look at this definition, it's just mem copy. So you can put mem copy there, it doesn't really matter. Anyway, now we're doing a cool. So this is what we're going to use to write to read-only memory. It's crazy, right? Like the function name describes what it does. It's crazy. So fuck. So I misspelled the function name there, obviously. IO allocat MDL. Very cool. Return false. Cool, and that's what we're giving it the read write. Nice. So yeah, what we're doing here is we're basically just mapping memory, and we're giving it the read write access. I think I spelled this wrong. It's meant to be cached. Cool. That looks good. Yeah, cool. So once we've done that, we can write the memory. So we're just going to write memory wherever it's mapped, and then the buffer size. Cool. And then we're going to need to clean up everything. So we're going to need to unmap the locked pages. And then unlock them. And then free the memory descriptor. Cool. And then we can return true because it worked. Isn't that cool? So that's all the memory functions I think we're gonna need. So I actually forgot a line in the memory file here. I forgot to add another query here. So we need to do ZW query system information again. And we're passing the same flag here, but this time we're going to use the modules variable. And I completely misspelt it. There you go. So that's the line I forgot. Add that line and then it should work. That's pretty much like the bulk of the coding. Now we can move on to like the hook, which is the fun part. So I'm going to do a new header file here. Hook.h. Cool. So for some reason I made a namespace here, so I'm just going to do the same thing again, I guess. Null hook. Doesn't that sound cool? I'm going to make this call kernel function. What's this going to do? It's going to call the kernel function. So empty status hook handler, and this is pretty much going to be our hook, right? And then this is the parameters that were given to the function. Coolios. Now we can code these out. So we're going to do basically we're going to set up the function that makes the hook, or sets the hook, basically. So that's going to be call kernel function, and it takes in whatever thing we want to hook. So this is going to be the address of our hook function. So we want to make sure that address is correct, or at least it's valid, because what's the point of trying to hook something if the hook isn't real? Function address. So we're going to return false if that's not valid. So we need to get the address of the function we want to hook. It's also called, I'm just going to call it function. And we're going to need to do a cast here. So reinterpret cast to a void pointer. Oh well. P void pointer. And we get to use that little function here, which is going to be get the export. So we need to pass the directory to the driver, which is in system root, system32, and then drivers, and then the name, which is dxgkernel.sys. I think that's right. Let me system root, system32. Yeah, cool. And then the name of the routine that you want to hook. So our one was query composition surface statistics. We want to make sure that's valid as well. So if not function turn false. It's going to be a byte array, and I'm just going to make this, I'm going to say orig. Basically, you just want it to be 12 bytes long. Doesn't really matter what this is. So basically, what you can do here is you can put the original instructions from the function. So when you disassembled it, you could see the original instructions there, and you could copy paste the bytes into here. Basically what that would mean is when you do the hook, right, if there's leftover bytes in this array, it'll put the right bytes in, if that makes sense. But basically the way I do it is there's not going to be any leftover bytes because I only need 12 for the hook, and I'm going to put 12 in this array. So it just doesn't really matter. I'm just, as long as this is 12 bytes long, which I don't know what I'm up to. I'm up to 1, 2, 3, 4, 5, 6, 7, 8, I think. Is that 12? You can just hover over here and you can see the size of the array. So it's 12. Cool. So that's 12 bytes, which is how long our hook is going to be. Now, if it was like a detour hook where it runs the hook and then it goes back to the original function, that's when it would matter to put the actual original bytes in here, because you don't want to crash, basically. You want to have the right instructions that are meant to be executed. But since we're not returning to the original function, it's just running our hook, it doesn't really matter. As long as there's enough space for our hook, that's all we care about. So we got our shellcode here, and that's going to be 0x48, 0xb8. And what that translates to is this is jump and this is racks. So it's going to be jump rack. Oh, sorry, move racks, not jump racks. That's the next one. So this is going to be move racks. And then afterwards would be our function address. So it would be something like, you saw the original. I did show you guys the actual instructions. I did show you guys the actual assembly in the WinDBG, if you remember that, but I'll just kind of type it out here. So it would be move racks, if you remember, and then it was like FFFFF, whatever our address was, right? So that's what this line's doing, and then the next one's going to be the end. Alright, so this is jump racks. So it's jump racks, cool. Yeah, so this is jump racks here. So that's very simple. It's just jump racks. And what's in racks? Our function address. So it's going to jump to our function, our hook function. Now we've got that shellcode set up. We're going to do the actual writing of memory here. Now I just want to say, this right here is what's detected by Battleye and Easy Anti-cheat, okay? They sig scan for this. They sig scan for a move racks and a jump racks, okay? So if you change the signature of this shellcode right here, it's going to be undetected by BE and EAC. That's all I'm going to say, okay? This is the method I use for my personal hack, and it's been undetected for like a month, okay? I use different shellcode, obviously. I'm not going to show you the shellcode, but I just want you guys to know you can actually make this undetected very easily, okay? I'm going to say that. It's very easy. So hopefully that inspires you guys to mess around with this and change the shellcode. It'll be undetected. But if you want to just use this shellcode here, it'll still work, but it'll only be undetected by VAC, okay? You'll get banned in Battleye and stuff like that. So let me get to... So we're going to do the actual hook here. And we're going to put orig and the size of the original bytes. We're going to use memcopy here. We're going to typecast to a void pointer and then ulong pointer. Want to put a rig, and then the shellcode starts. Okay. Then we're going to get the hook address here. It's going to be another reinterpret cast. Q. This is saying bad. Why? Oh. Lamel. So you want to put another bracket after this thing here. I forgot about that. Anyway, we get the hook address. Now we're going to do another mem copy here. P void. It's going to be size of void pointer because it's just a pointer to a function address. And then we're doing another mem copy. I'm just going to copy paste this by now, honestly. Like this. It's going to be orig plus size of the shellcode. And we also want to do the size of the function address, which is void pointer. And then we want to put the end finally. And that's going to be the size of whatever that is. There we go. Alright, so now we're going to actually write the shellcode to the function. So this is where we're writing the hook. So this is the function address, and then we want to do our shellcode. And it's going to be size of the shellcode. So basically what we're doing here is we're getting the instructions ready to be written. So the first thing we're doing is we're copying the move racks into here, and then after the move racks we put the hook address, right, which is this here. Copy the hook address into there, and then lastly we're copying the jump racks at the end, which would be the last 2 bytes into there. That's pretty much the hook right there. That's how you hook it. So after that we want to return true because it actually hooked, and now every time that function runs it's going to run our hook. So now we want to actually write the hook function, right? We want to write the function that runs, and that's going to be called our hook handler, and we want access to the parameters here. So eventually this parameter is going to be our some sort of struct we're going to make, and that's going to store the instructions on what we want to do. But for now, just to cut this video short, honestly, it's going for way too long already. We're just going to make a return success to see if the hook works and see if it blue screens or whatnot. So I'm going to compile this, see if I get any errors. Hopefully not, actually. I haven't even made the main. Alrighty, so it's time to do the main function. And this is going to be easy. We just want to do extern C empty status driver entry, or whatever you made it in the linker settings. If you followed what I did at the start, it would be driver entry. And I'm spelling this completely wrong. Driver object. Alright, so since I'm using KD mapper, I can't actually use the driver object or the registry path, so I'm going to do unreferenced parameter for both of them. And then then we just need to call the hook. pass the address. Alright, so after that we just need to call the hook. Oh well, set the hook, and then pass our hook function, which is the hook handler, and that should be it. Then we can return success. Cool. So let's see, I do have some errors down here, so I'm going to see what they are. So it just means this is the last setting I forgot to do. It's treating warnings as errors. So I think that's in, is it in C++? Yep, here we go. Treat warnings as errors, you want that as no. And then it should let you compile. Awesome, so I'm gonna hop in my VM and try load it and see what happens. Alrighty, so I'm in my VM now. I've compiled the driver and I've disassembled the function here. So let's see if it works. I'm gonna load it with KD mapper. There we go, the hook works. So we've got the move racks and then the address of the hook function. And then we jump racks, simple as that. I'm going to go to the hook address here, and you can see, like before, it's just returning. Yeah, so that's basically it. The next part to this is going to be adding the user mode client and communicating with the driver and adding that memory struct to make the driver read and write and do what we want. So that's going to be the next episode. This one was long enough on its own. I hope you guys learned something from this. Comment down below if you got any other series ideas, any video ideas. Leave a like as well, subscribe, and once again, Patreon down in the link below. You can get the source code from this video and all my other videos, $5 a month.